Ever looked up at Mars, that reddish beacon in the night sky, and wondered, why can't we just go there? It seems like a natural question, doesn't it? We see it there, seemingly within reach. It seems so close, a quick trip, right? Just hop in a spaceship and off we go. In movies, spaceships zip between planets like it's a drive down the street. They make it look so easy, a simple point-and-go affair. But real space travel is nothing like that. The reality is far more complex and challenging. It's more like throwing a dart at a moving target, a target that's incredibly far away and constantly changing its position. While you're on a moving platform, imagine trying to hit that dartboard while standing on a merry-go-round. Everything in space is in constant motion. It's a cosmic dance of epic proportions. Earth, Mars, constantly orbiting the sun at different speeds and distances. The whole solar system. It's a dynamic environment, not a static map. You can't aim for where Mars is now. That's like aiming at a ghost. You have to aim for where it will be months from now, predicting its future position with incredible accuracy. One small miscalculation, a tiny error in trajectory, and you'll miss by millions of kilometers. You could end up lost in the vast emptiness of space. Even the Apollo missions to the moon, our closest neighbor, a mere hop in cosmic terms, required precise timing and complex maneuvers. They were a testament to human ingenuity and meticulous planning. They used orbital transfers, not straight lines, carefully calculated paths through space, to save fuel and use gravity to their advantage. They harnessed the power of celestial mechanics. Every interplanetary journey is a dance of physics and timing, a delicate balance of forces and trajectories. So next time you look at the stars, remember, the seemingly simple act of getting from one planet to another. Getting there is a grand challenge, not a straight shot. It requires immense planning, precision, and a deep understanding of the cosmos. The question, why can't we just go, opens up a universe of science and ingenuity, pushing the boundaries of what's possible. The journey itself is as much the adventure as the destination. It's a testament to human curiosity and our relentless pursuit of knowledge. Let's talk about distance, the ultimate frontier. The sheer scale of space presents unique challenges that we must overcome to explore the cosmos. On Earth, a long trip might take days, maybe even weeks if you're crossing continents. We're used to thinking about distance in terms of hours and days. In space, however, it takes months or years to reach even our closest planetary neighbors. The timescales are vastly different. The Moon, our nearest celestial companion, is 384,000 kilometers away. It seems far, but in cosmic terms, it's practically next door. That's 3 days by rocket, a testament to our engineering prowess, or a staggering 6 months if you were to drive. Imagine that road trip. What about Mars? At its closest approach, it's still a considerable 55 million kilometers away. But sometimes, due to the orbital dance of the planets, Mars is on the other side of the Sun, a mind-boggling 400 million kilometers. Consequently, a robotic mission to Mars, even with our most advanced technology, takes about 7 months, relentlessly flying through the seemingly infinite emptiness of space. It's a long and lonely journey. To truly grasp these immense distances, let's try a scale model. Imagine the Sun reduced to the size of a grapefruit. On this scale, Earth is a mere grain of sand, orbiting our grapefruit sun at a distance of 15 meters. And Mars? It's another grain of sand a bit further out, at a distance of 23 meters. The vastness between these tiny grains of sand, representing entire worlds, is the first and biggest hurdle to interstellar travel. The longer the journey, the more supplies, water, and, crucially, fuel you need to carry. The logistics are staggering, and of course, the longer the mission, the more opportunities there are for things to go wrong. Therefore, every mission, no matter how small, must be planned with incredible efficiency, meticulous detail, and unwavering patience. The sheer scale of our solar system, and indeed the universe, fundamentally shapes every single aspect of space travel. It's not just empty space. It's a profound and fundamental challenge that pushes the boundaries of human ingenuity. Crossing these immense distances requires not only smart engineering, but also incredibly careful and innovative planning. The emptiness, the sheer void, is what makes every mission so incredibly difficult, and ultimately, so profoundly impressive. That's precisely why every successful journey, every arrival at a distant world, is such a remarkable triumph of human endeavor. Planning a trip to Mars? It's not like packing for a weekend getaway. You have to pack absolutely everything you'll need, every single necessity for survival and scientific exploration. This includes not just the obvious, but also backups for the backups. Air, breathable and pure, water, clean and plentiful, food, nutritious and long-lasting, fuel, the lifeblood of the entire journey, all accounted for right from the start. There's no popping out to the store when you're millions of miles from Earth. Every extra gram means more fuel, a heavier load to escape Earth's gravity, thanks to the tyranny of the rocket equation, which dictates the exponential relationship between fuel and payload. Most of a rocket's size isn't cargo, it's just fuel to lift its own weight and the weight of more fuel. It's a daunting challenge. For a Mars mission, astronauts need supplies for up to 3 years, considering the travel time and surface stay. Recycling is absolutely essential, reducing the amount of mass you need to launch in the first place, just like the ISS, which recycles most of its water, turning waste into a resource. Advanced life support systems, capable of regenerating air and water, and lightweight systems are a must to minimize the overall mass. You also need a full suite of scientific gear for conducting experiments, plus all the repair tools necessary to fix anything that might break down. Pressurized habitats to live and work in, and of course, fuel for the long return trip back to Earth. That's precisely why robotic missions are so incredibly valuable. They don't need food, water, or a return ticket, significantly reducing the mission's complexity and cost. As a result, they're lighter, more agile, and can explore farther reaches of space. Every single ounce must be rigorously justified, every system meticulously optimized for peak performance. Packing for another planet isn't just logistics, it's a massive, intricate engineering puzzle demanding innovative solutions. It drives critical innovation in recycling technologies, pushing the boundaries of what's possible. It also fosters miniaturization of components and overall system efficiency, leading to lighter and more capable spacecraft. Ultimately, the immense challenge of packing shapes every mission we send beyond Earth, influencing its design and capabilities. Once you leave Earth, space becomes a hostile obstacle course. Radiation is a major threat. Without Earth's magnetic field, astronauts and electronics are exposed to cosmic rays. Shielding helps, but it adds weight, making the rocket equation even tougher. Temperatures swing from scorching to freezing, so spacecraft need advanced thermal controls. Then there are micrometeoroids, tiny, fast-moving particles that can puncture a spacecraft. Multiple layers of shielding act like body armor to protect against these cosmic bullets. Surviving deep space means designing for radiation temperature extremes and impacts. Every mission is a test of engineering resilience. The dangers of space are real, but so is our determination to overcome them. After months in space, landing is the most nerve-wracking part. On Mars, you hit the atmosphere at 20,000 kilometers per h. The thin air means parachutes alone won't slow you enough. Landings use heat shields, parachutes, and retro rockets, or even sky cranes for rovers. On airless worlds like the Moon, it's all rocket engines and careful piloting. There's no room for error. One mistake, and the mission is lost. Because of the time delay, landings are automated. By the time we get the signal, it's already over. Every landing is a high-stakes, one-shot deal. That's why each successful touchdown is a huge achievement. The 7 minutes of terror on Mars is legendary for a reason. Landing safely is the ultimate test of engineering and precision. It's the moment that makes or breaks the mission. Landing is hard, but coming home is even harder, especially for humans. Robotic missions stay forever, but astronauts need a return ticket. That means bringing or making a rocket and fuel for the trip home. On the Moon, a small ascent stage was enough. Mars, with its stronger gravity, needs a much bigger rocket. Carrying all that fuel from Earth is nearly impossible. The solution? Make fuel on Mars using local resources, like turning Martian air into oxygen for rocket fuel. NASA's MOXIE experiment is already testing this idea. The return journey is long and dangerous, ending with a fiery re-entry to Earth. A round trip to Mars could take up to 3 years. It's the most ambitious journey ever attempted. Solving the round-trip challenge is key to future exploration. With all these challenges, why do we keep reaching for the stars? Because we're explorers at heart. Space missions drive innovation, inspire new generations, and teach us about our place in the universe. Every discovery, water on Mars, oceans on Europa, changes our understanding of life and the cosmos. Technologies from space travel improve life on Earth, from GPS to medical imaging. The quest to explore makes us smarter, more capable, and more connected. Yes, it's hard, but it's the greatest adventure we've ever undertaken. The rewards, knowledge, inspiration, and wonder are immeasurable. By reaching for the stars, we learn more about the universe and ourselves. The journey is tough, but it's one we must continue. Our future depends on our willingness to explore the unknown.